Hi, this is Mrs. Rodriguez, your geometry teacher. This video is a review for the Chapter 9 test that's coming up. I did not take these questions from the practice test that's in the textbook. I just didn't think too many of those questions matched up to what the test was going to be like. So I did find some that are very similar to the test. So I'm going to go over those problems. Okay? All right, here we go. Let me share my screen. So like I said, this is a review for Chapter 9. And the first lesson talks about a reflection, or reflections. And so a reflection is a transformation representing a flip of a figure over a point, a line, or a plane. Okay? So if you have a reflection over the X or Y axis, so if you have a reflection over the x-axis, you multiply its y-coordinate by -1. And if you have a reflection over the y-axis, you multiply its x-coordinate by -1. Okay? So here it says, given that point C with coordinates 2, +2, 9, under which reflection is C +9, +2, okay? So is that going to be reflected over the x-axis, reflected over the y-axis, reflected over x equals 2, or reflected in the line y equals x? So if we look back, to be a reflection over the x-axis, then you would multiply the y-coordinate by -1. So if your y-coordinate is 9, if we multiply 9 by -1, well, that would be -9, okay, which is not what we end up with, okay? And then if you reflect over the y-axis, then you would multiply the coordinate in the x-coordinate by -1. So then we'd multiply 2 by -1, and then we would get -2, +9. Okay, well, that isn't the point that we ended up with either. Okay, so it's not going to be reflected over the x-axis or the y-axis. So then the question is, well, is it reflected over the x equals 2? So what I would do is I would draw a little sketch here of a coordinate plane. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so and I would plot these points. So this is +2, +9, so that's about right there. And this is +9, +2. Okay, and this is C, and then this is the reflection of C. Okay, so the other option is that, or option C says it's reflected in the line x equals 2. Well, x equals 2 right here. So it's not going to be a reflection because remember, in order to be a reflection from a line, the points have to be the same distance from that line. Okay, and this one is right on the line, and this one is like 7 spaces away. So that's not going to be a reflection. So we have option D that says it's reflected in the line y equals x, and that would be like a line like this, okay? And so that is our answer, okay? It's reflected over the line y is equal to x, okay? So it has to be D, okay? All right, next problem says name the image of KL, side KL, under a reflection in a vertical line through point N. Okay, so a vertical line through point N. Here's point N. If we put a vertical line straight through that point, okay, we want a reflection of KL. So it has to be the same distance from this line here that goes through point N. So the only thing that's going to be the same distance is this line here, okay? And we know that because the length of these two sides is the same, and this is the midpoint here, halfway between each of these lines. Okay, so that would be side JM. Okay, that would be the reflection, okay, of KL. All right, next problem. Our next section talks about translations, and a translation is a transformation that moves all points of a figure the same distance in the same direction, okay? And a translation maps each point to its image along a translation vector. So here we have, it says to translate a point along vector AB, you add A, when you're given the vector, you add the value of A to the X coordinates of whatever point you're looking at, and then you add B from the vector to the Y coordinate, okay? So here they had the example, this point, -2, +3. It's translated along vector 7, 4, okay? So the translation of that would be, the translation of P would be +5, +7, okay? All right, so you will have several problems like that on your quiz. So this one says to name the image of point Z, which is -11, -6, along the translation vector 1, 7. So remember what we just discussed. You would take the X coordinate and add the Y value from the vector, and then the Y coordinates and add the B value from the vector, okay? So then it's just a matter of plugging in your values. So the X value is -11, and then the Y value here is 7, so we would add 7, and then, I'm sorry, go back. The Y value, I'm sorry, the value of A in your vector is 1. Sorry about that. Okay, and then we have the Y value as -6 plus the B value, which is 7, okay, of your vector. So then -11 plus 1 would be -10, and then -6 plus 7 would be +1. Okay, so this would be our final answer. Okay. Next problem. A point R with coordinates +3, -1 is translated along the vector -2, +3, and then reflected in the x-axis. What are the coordinates of the reflection of R? Okay. So first thing, just like we did in the previous problem, we are going to take the x coordinate and add the value of A in the vector, and then take the y coordinate and add the value of B. So when we do that, the x coordinate is +3, plus the A in the vector is -2. And then the y value is -1, plus B from the vector, which is 3. Okay. So 3 plus -2 would be +1, and then -1 plus 3 would be +2. Okay, so that is the translation of R, okay? But then it says, and then it's reflected over the x-axis, okay? So remember, when you reflect something over the x-axis, you multiply the y coordinate by -1. So here we have our coordinate, oh, just kidding, we're using this here, the coordinates +1, +2. We are going to multiply the y coordinates by -1, okay? So we'd have 1 and then 2 times -1, and then that would be 1 and -2. Okay, so that would be the reflection after the translation. Okay, so this is the final answer. So there's 2 steps to this problem, because it's first asking you to translate it along a vector, and then it's asking for the reflection of that translation. Okay. All right, and then the next one says, LMNO is a trapezoid with coordinates, then it gives you the coordinates of each of the points. Find the coordinates for the image of n along the translation vector -7, +9. So we only need these coordinates here, this 5 and -3, because it's only asking about n. Okay, so remember we're going to take the x value and add the value of a, and then the y value and add the value of b in order to get that translation. And then when we do that, we have the x value, which is 5, and then a is over here, -7. And then the y value would be -3 plus the b in the vector, which is +9. So 5 plus -7 would give you -2, and -3 plus 9 would give you +6. Okay, so that is the final answer. Okay, so you didn't have to do that for each point of the trapezoid. It was only asking for one of those points. Okay. And then this one says, find the image of point D, +3, +4 under translation by the vector -7, +2. So same thing. So you're going to have several problems where you have to translate a vector. Okay. So you're going to use that same formula here. So at the x value of the point that you're given is 3, and the a value of the vector is -7. And then the y value is 4 plus the b value, which is 2. And then 3 plus -7 would give you -4, and 4 plus 2 would be +6. Okay, so that would be your image of, I guess we would label this reflection or translation of D. Okay. All right, so then the next section talks about rotations, okay? So a rotation turns each point in a figure through the same angle about a fixed point, okay? And you're given this chart here. This is very important because it tells you what you're gonna do depending on how many degrees the rotation is. Okay, so if we have a 90 degree rotation, if you have a 90-degree rotation, you're going to multiply the y coordinates by -1 and then interchange the x and y coordinates. If you have a 180-degree rotation, you multiply the x and y coordinates by -1. And a 270-degree rotation, you're going to multiply the y coordinate by -1 and then interchange the x and y coordinates. Okay? So let's look at some of these. So we have, it says name the image of point C, which is +6 on -4 under a rotation 90 degrees about the origin. So for a 90-degree rotation, you're going to multiply the y coordinates by -1, then interchange x and y. Okay. Okay. So let's go ahead and do that then. So we're going to take the y coordinate. These are our coordinates. So we have 6 and -4. We're going to multiply -4. That's our y coordinates by -1. Okay. So then when we do that, we still have that +6, and now -4 becomes +4 because negative times negative is positive. And then it says interchange x and y. So we're going to flip x and y around. So now y becomes the x value and the x value becomes the y value. So that's +4, +6. Okay. And then next problem says the line segments for TU with endpoints, T is at +2, +1, and U is at -5, +6. Is rotated 90 degrees about the origin. What are the coordinates of T? Okay, so we just want this value here, okay? So again, this is another 90-degree rotation. So we're going to multiply the y coordinates by -1. And then that would give us +2 and -1. And then we're going to switch, interchange the x and y values. So this -1 becomes our x value and +2 becomes our y value. And that is the final answer. Okay. Okay, and then next lesson talks about a translation, compositions of transformations. It says a translation can be represented as a composition of reflections in parallel lines, and a rotation can be represented as a composition of reflections in the intersecting lines. Okay. So we have this theorem here. It says reflections in intersecting lines. So the composition of two reflections in intersecting lines can be described by a rotation about the point where the lines intersect, okay, and through an angle that is twice the measure of the acute or right angle formed by these lines. So here we have the original point A, and then we have the reflections here, okay? And so you're going to be asked what is the angle of rotation from this point to the final point, okay? And then you have these intersecting lines, and you'll be given this value here. You'll be given one of the values. So if you're given the degrees that the two intersecting lines make when they cross each other. Okay, so from the original point to the final point, you would multiply that whatever that degree is that you're given. You're just going to multiply it by 2. Okay, because this has moved twice, right? Same amount of rotation. So here it says to find the angle of rotation of a figure that is reflected in two lines that intersect to form a 66-degree angle. Okay. So you have these 2 points, right? Or this figure, we can make them 2 points, okay? And it is they are reflected in two lines that intersect to form a 66-degree angle. So you have these 2 lines, and then here it would be 66 degrees, okay? We want to know the distance, the angle of rotation from here to here. So remember, if this is equal to x, this would be 2x. So we would multiply 2 times 66, which is equal to 132 degrees, okay? All right. Next problem. Our next section talks about symmetry, and it says the line of symmetry in a figure is a line where the figure could be folded in half so that the two halves match exactly. And the number of times a figure maps onto itself as it rotates from 0 to 360 is called the order of symmetry. And the magnitude of symmetry is the smallest angle through which a figure can be rotated so that it maps onto itself. Okay. So here we have the question, how many lines of symmetry does a regular 12-gon have? Okay, and so the number of sides is always the same as the number of lines of symmetry. Okay, so here is a drawing of a 12-gon, okay, and it has 12 sides, so it's the number of lines of symmetry is going to be the same. Okay, so it's going to have 12 lines of symmetry, because each one of these lines would cut that figure in half. Okay. And then next section talks about, or same section, but a little more detail here. The number of times a figure maps onto itself as it rotates from 0 to 360 is called the order of symmetry. And then the magnitude of symmetry, or the angle of rotation, is the smallest angle through which a figure can be rotated so that it maps onto itself. The order and magnitude of a rotation are related by the following equation. So we can take the magnitude, and that's going to be equal to 360 degrees divided by the order. Okay, and remember that's the number of times the figure can map onto itself as it rotates from 0 to 360. Okay, so here we have this figure, and you turn it, and it's moved. You can turn it 4 times, and then you end up with the 360. So this figure has a rotational symmetry of 4 and a magnitude of 90. Okay, so going back to what it said over here, you take the magnitude is equal to 360 divided by the order. Okay, so the magnitude equals 360 divided by the order, right? And since you can rotate this figure 4 times, it's 360 divided by 4, okay? Which would be 90 degrees, which is the magnitude, okay? All right, so it says, which of the following regular polygons has a magnitude of symmetry of 72? Okay, so we've got, now we know the magnitude, and remember it's 360 divided by the order, okay? So we can say, write this as an equation, 360 divided by, let's call it x, whatever the order is going to be, okay? So here, what we're going to do is, just change. We're going to multiply both sides by x. So then we have 72x equals 360. And then we would divide both sides by 72 to solve for x. Remember, we're trying to figure out the order here, the value for the order. So 360 divided by 72 is 5, okay? And which one of these has 5 sides? A decagon, a pentagon, a hexagon, or an octagon? And that would be a pentagon that has 5 sides, okay? All right, and then here it says, talks about dilations. Dilations enlarge or reduce figures proportionally, okay? So this says, what type of dilation occurs with a scale factor of 1, okay? So they represent the scale factor with the value k. So if k is less than 0, then it is a reduction, okay? If k is greater than 0, then that would be an enlargement, okay? And if k is equal to 0, then that would make the figures congruent, okay? All right, so if the question here is asking about a scale factor of 1. I'm sorry, just 1 second. These should all be 1. If k is less than 1, it's a reduction. If k is greater than 1, it's an enlargement. And if k is equal to 1, then they are congruent, okay? So if the scale factor is 1, they're going to be congruent, okay? Sorry about that. This should be k less than 1, k greater than 1, k equal to 1. All right. So then here, oh, this is what I was saying. If k is greater than 1, then it's an enlargement. If k is between 0 and 1, then it's a reduction. And if the scale factor is 1, and it's called isometry dilation, okay? And it basically, the two figures are congruent to each other, okay? All right, so next question says, Stella carved an equilateral triangle that is 3 centimeters on each side on a pumpkin. Then she carved another equilateral triangle that is 5 centimeters on each side. What scale factor did Stella use to increase the size of the triangle? Okay, so for the scale factor, we use this equation here. We have the image length over the pre-image length. Okay. So the image length would be 5 centimeters, and the pre-image, that's what you started with, would be 3 centimeters. Okay. So our scale factor is 5/3. Okay. All right, so those are all the problems that I have for you to review for the test that's coming up. If you're able to attend the live session, I strongly encourage you to do that. If you went through all these problems and you had questions about them, make sure that you get your questions answered before you take the test. So you can call, text, email me, or stop by my office hours, and I'll be happy to help you. Okay, you have a great day and good luck on your test.